Hello everyone. I've been really getting into game theory lately, so here is yet another game theory problem. So, here we have a bowl of 5 cookies, and here we have a bowl of 8 cookies. And you are allowed to take as many cookies you want from one bowl or both. And the question is there a winning strategy for any one of us? Yeah, and we take turns taking cookies from these bowls. Yeah, so the question is there a winning strategy for any one of us? And to do this, we do a win-lose matrix. Yeah, that is essentially what we do. So we start from the bottom up, thinking that okay, if there are 0 cookies in one of the bowls, then you've obviously won because you can just take them all from this one. And the same thing holds for the opposite. If there are cookies in this one but none 0 in this one, then you can just take all of them. And if there are the same amount of cookies in both, then you can also just take all of them because you're taking the same amount from both, which is all, and then you're taking the last cookie, so you won. And so this is okay. These are the obvious cases where we just win if we were to choose from that state. But now let me draw a little matrix real quick. So here, the rows represent the amount of cookies in the left jar or bowl, and the columns represent the amount of cookies in the right bowl of in the right bowl, the amount of cookies in the right bowl. So here, okay, we can just start with the things I said before. So in this case, if you are asked to choose when there are no cookies left, then you've obviously lost already because your opponent has your opponent won last round. So this is an obvious lose. And that means that, as we said before, if there are 0 cookies in either bowl, or there are an equal amount of cookies, then you've won because then you can win instantly. So therefore, this is a win situation. This is a win. This is a win. This is a win. This is a win. And here we have when there are no cookies in the left jar, then we've won all everywhere over here. And when there are the same amount of cookies in both bowls. And this is the position we're starting at. This is our start here. And so we essentially what we want to do is we want to figure out if this is a winning position. But starting from this, is this a winning position? And here, what can we observe now? Okay, well, we want to add more losing positions. Well, what should come to mind is these 2 boxes here. If you are here, then you can only put your position into this one, that one, or this one, which are all winning positions, and therefore this is a losing one, and this applies to this box too. And then, because this is a losing one, we could do the same thing before, when we just fill in the columns and the diagonal and the rows with W's, because these are also winning positions. Because if that is a losing position, that every position that is eligible to put your opponent into this position, then that is also a winning one. So therefore, we do the same thing here. We fill in, we take this
one, and then we fill in the row, the column, and the diagonal. So this is winning, 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 and this one is also winning, 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 and winning. And then we do the same thing for this one. So we just fill, okay, here's the diagonal, and then the column,
and then the rows. So you can see there are a fuck ton more winning positions than there are losing ones, meaning that starting is probably the best one. And here, what do we have here? Now we need to find more losing positions. And how do we do that? Well, we essentially do the same thing here. So we have these two boxes. If you put here, you can only place your opponent in these, or these positions, and which all of these are winning. So this is also losing, and therefore we can immediately conclude that this entire row is winning, except that one, of course. So therefore these two are winning, and that one is also winning. So the optimal strategy here, or sorry, one optimal strategy here, is to, from this position, you take 5 cookies from this jar. So we can just sketch down what happens. Okay, so we have 5 and 8. And then we claim that if you make the 8 cookies bowl contain 3 cookies, then you put your opponent in a losing position. So therefore, okay, this then becomes 5, and then we took 5 away from this one, so then there's 3 left. And here, what can your opponent do? Well, they can put you in either any one of these. So, well, maybe we'll say that they do that. Maybe they take 1 from each. And then we have 4 and 2. And what do you do here? Well, again, we want to put our opponent in a losing position. So we take 3 away from that one. So then this one, we take 3 away from that one. So now it's 1, 2, and we are here, right? Yeah, that's what I didn't. Yeah, okay, we went from there to there to there to there, and here they can either put us here, meaning that they take away the last cookie and then there's 2 left in the second bowl, or they can do that, take 1 from each, and then there's just 1 left in that one. They can do that, meaning that they take 1 from this one and then there's 1 in both, or they can take 2 away from that and then there's 0 in that one and 1 in that one. So either case, say that they take 1 from that, so it's 1, 1, and therefore we ended up here, and then we can just take 1 from both. So then it's 0, 0, and we've won. So the path we took here was that we sent our opponent into a losing position, and then they have to put us in a winning position. So in this case, we did, what did I do? I took 1 from both, right? Yeah. So and then they had to put us in a winning position, and they choose this. And then we put our opponent in a losing position, and then they put us in a winning position, and then we took the final cookies. So yeah, this is a so-called win-lose bracket or matrix. I don't know what you actually call it. So yeah, that was basically the lesson for today. Hope you enjoyed the video, and have a good one. Bye-bye.